Now for this topic, we'll be looking at your kinetic particle theory 2, changes in state. Now previously you have learned about the separation as well as the arrangement and movement of the particles of your solid, liquid and gases, like what you have seen on this slide so far, which summarizes everything that you need to know. So these are the key words and phrases that you would need to memorize, okay, and it's very important for this chapter. Now in this chapter, then what will we be learning? Now we'll be learning the few different changes in state that you will see on the slide. Now first of all, we're looking at your melting, boiling, condensation, freezing. Now these are a few of the more common changes in state that I would expect you to already know, and on top of that you'll be learning this change in state called sublimation. So this is something new. On top of that, you'll also be learning how to describe each changes of state in terms of whether energy is absorbed or released, and how, right, the changes in the movement as well as the arrangement of the particle from one state to another. And last but not least, you will need to learn how to draw and interpret a heating or cooling curve. So what are changes in state? Now as I have mentioned before, changes in states is something that you should be familiar with. So during these changes in state, right, heat can either be gained or lost. Now the heat that is gained or lost, the particles in matter actually gain or loses heat energy, and because of this will cause changes to the movement and the arrangement of the particles in the matter that you have learned in the previous chapter. Now according to kinetic particle theory, these changes to the movement and arrangement of the particles, right, it will actually lead to a change in state. So maybe your matter can change from a solid to a liquid, or perhaps from liquid to gas, for example. So what you know so far is that matter can change its states, and this change in state is actually reversible. So I give you an example. Let's say I have water and I freezes it to become ice. Okay, now the reverse process, of course, if let's say I have ice and I actually melts it to become water or become a liquid again, so that process will be melting. So I say that these changes in state, they are actually reversible. So now let's take a look at some of the processes that you'll need to learn. So the first process is, of course, your melting. So this process will occur when there's a change in state from your solid to liquid state. Alright, from a solid to a liquid state. Now please copy down the brief description in your notes. Now the second process that I'm looking at, of course, is your boiling. Now your boiling will occur when there's a change in state from your liquid to gas. Now the next few processes that I'm looking at, condensation. Condensation will be the process where you have your gas when it changes to a liquid, freezing when you have your liquid changes to a solid, and last but not least, sublimation, where there's a change from your solid straight to a gas. So for your sublimation, which is something new, your solid actually changes into a gas without actually going through the liquid state. Now we'll talk more about this slightly later. So now let's take a look at the first physical process, melting. So exactly what is melting? Now your melting is a process in which your solid changes into a liquid. Now during this process, heat is absorbed during melting. And of course, very importantly, your melting takes place at a fixed and sharp temperature, and this is called the melting point. Now let's take a look at this experimental setup over here that is used to measure the melting point of your stearic acid. Alright, so what you do is that you have a solid stearic acid over here, and with that, right, we actually use the thermometer to measure the temperature in which your stearic acid actually melts from a solid and it changes to a liquid. Okay, so it's placed inside this water bath and heat will be supplied to it. Now, if I have the experimental set up like what I've just described, and we actually plot, okay, I maybe every few seconds, right, I take the temperature that I see on the thermometer previously, and I draw a graph after that, I will be able to get a graph with a shape like what you are seeing on the screen now. Okay, so as you can see over here, the graph will go up. There's an increase in the temperature from part B, and then in this part of the graph for part C, I will have the temperature remaining constant, and after that in part D of the graph, the temperature will continue to increase again. So this diagram is what I call a heating curve. Now, some of the key questions that you need to know for a heating curve is that you need to be able to understand what does A actually represent. Alright, there is a reason why we actually label A. So this is one of the more important things that you need to know. And of course, what are the different states of matter that is present at part B of the graph, part C, as well as part D of the graph. Now next, you also need to know how to interpret the graph and explain it using kinetic particle theory. And last but not least, if you still remember, at part C of the graph, right, you actually see that the temperature actually remains constant during that part of the graph. So you will need to be able to explain why is this so. So now, let's take a look at the heating curve for changing a solid to a liquid then. So previously you have A, B, C, D. I'm going to just go according to what you have seen previously. So for A over here, this part labeled A will actually show us the melting point of the substance. So this will be a sharp and fixed temperature over here. Alright, and then I'll move on. For this temperature time graph, if you look at part B, you'll realize that at the starting part of the graph actually does not start here. Okay, it doesn't start from 0. Why is this so? It's because usually when we start the experiment, right, we do not start the experiment at 0 degrees Celsius. We actually start the experiment at room temperature. So that is why when you start to draw the graph needs to start from around 25 degrees Celsius, which is your room temperature. So this explains why the graph does not start at 0. So the start of the graph, because you know that this is a heating curve for changing a solid to a liquid, you will have the solid at the start. So for part B of the graph, your matter actually exists in the solid state. So as you can see, as we start to heat the matter, your temperature will start to increase until we reach the melting point of the substance itself. So what happens here? Now once we reach the melting point, the melting will start. Alright, and once the melting starts, you will realize that the temperature will remain constant. It will not increase further until melting has completed. That means all the solid has melted to form your liquid. So in between, okay, this part of the graph, part C of the graph, the substance actually exists in both the solid and the liquid state. So this is very important. Please take note. During the process of melting, your substance exists in the solid and liquid state. It's only after your melting completed and then the temperature starts to rise, where your substance will only exist in the liquid state. So this is how you interpret your heating curve. So what happens when a solid is heated? Now, the particles will gain heat energy and they will start to vibrate faster. So as you have learned previously, your particles of solid, they will only vibrate and rotate about their fixed position. And as the temperature increases, right, the vibration of the particle will also increase. So they'll be able to vibrate faster and faster. And eventually, the particles will be able to overcome the forces that hold them together in their fixed position. And when this happens, right, the solid changes into a liquid. Now let's take a look at an example from the previous experiment that I described to you, the experiment on the stearic acid. So now if you take a look specifically for the heating curve of a stearic acid, right, you can see over here, it is labeled for part A 69 degrees Celsius. So what you need to know, right, from this graph is that the melting point of your stearic acid is actually at a fixed and sharp temperature of 69 degrees Celsius. So before that, from 25 degrees all the way to 69 degrees, your stearic acid will exist in the solid state. And once the melting starts at 69 degrees, the temperature will remain constant and it will exist in a solid and liquid state until all the stearic acid has melted. After that, only after that, will the temperature continue to increase. And of course, all your stearic acid now, it will exist in the liquid state. So how do you interpret this graph then? Like what I mentioned, the melting point of your stearic acid is 69 degrees Celsius. The temperature of the solid will increase until it reaches the melting point of your stearic acid. And at 69 degrees Celsius, your stearic acid will start to melt. And of course, at the melting point, the temperature will remain constant because your heat energy is absorbed to overcome the forces of attraction between the particles and to separate the particles. So that's why the temperature does not increase until all the stearic acid has melted. Now if you take a look over here, what I want to show you over here is that different substances have different melting point. One of the common mistake that students make is to think that all substance melts at 0 degrees Celsius. This is not true. Only ice melts at 0 degrees Celsius. I'll give you an example. Oxygen has a melting point of negative 219 degrees Celsius, which is a very, very low melting point. Whereas if you compare a metal like iron has a melting point of 1535 degrees Celsius. So I've come to the end of the first part or the first process, which is your melting. Now the next physical process that we'll be looking at is your boiling. So very similar to your melting, boiling is a process in which a liquid changes into a gas. This change occurs inside the liquid and heat is absorbed during boiling. And of course, similar to your melting again, boiling takes place at a fixed and sharp temperature, and this temperature is called the boiling point. Now, let us take a look at the heating curve for changing a liquid to a gas. If you realize the general shape of the graph is very similar to what you have seen previously. Take a look at the part A of the graph that we have previously discussed. You realize that it is the same, except for this time round, part A is actually the boiling point of the substance. Again, I have a fixed and sharp boiling point over here. Now what is different then is that at the start now, Okay, for part B of the graph, instead of having a solid like what I have previously, I have a liquid. Okay, so I want to change from a liquid to a gas. So I start heating up this liquid. Temperature, again, it doesn't start from 0, it starts from 25 degrees Celsius, will increase until it reaches the boiling point, at which the temperature will remain constant until the boiling has completed. Okay, thereafter, temperature will continue to increase. Alright, so at this part of the graph, again, when there's a change in state, your substance will exist in both the liquid and the gaseous state. So this is very important. Okay, after boiling has completed, then your substance will exist in the gaseous state. So again, what happens when a liquid is heated? Very similar, the particle will again gain heat energy, they will move faster. This time round, as the temperature increases, the movement of the particle will also increase. So eventually, right, the particles are able to overcome the forces of attraction between the particles and break free from one another. So now the liquid changes into a gas. Now, let's take a look at the heating curve. Continuing from the same experiment, right, I can just continue to heat and I will be able to obtain a heating curve for your stearic acid. So this time around is for boiling. Now, take note, take a look over here. For part A, the label is now different. So the boiling point of your stearic acid, from this graph, you should be able to tell that it should be 361 degrees Celsius. Alright, the rest of the graph will remain the same. So from the graph, we can actually tell that the boiling point of your stearic acid is 361 degrees Celsius. The temperature of the liquid increases until it reaches the boiling point, which is 361 degrees Celsius. After that, your stearic acid will start to boil. Now, what about evaporation then? Now, very similar, and often students confuse evaporation with boiling. So for this part of the chapter, we'll be looking and comparing the differences between your evaporation and your boiling. Now, your evaporation in this case is a process in which a liquid changes into a gas. This is similar to boiling, but the difference is that this change in state takes place only at the surface of the liquid. Alright, it takes place only at the surface of the liquid. And of course, your evaporation, right, actually takes place at all temperature below the boiling point of the liquid. Alright, it does not take place at the boiling point of the liquid. And liquids which evaporates quickly at very low temperature, right, we call them volatile liquids. So let me explain this a little bit further. Now, let us take a look at your particle A and particle B. So for your particle A, right, because your particle A is at the surface of the liquid, it can actually overcome the attractive forces and escape the liquid to form a gas. Whereas if you take a look at your particle B, it is surrounded by surrounding particles in all directions and it cannot escape. Alright, so therefore evaporation only can take place at the surface of the liquid. So now let's take a look at some key differences between your boiling and evaporation. Now, your boiling only occurs at your boiling point. For example, water boils at 100 degrees Celsius, so your water will only boil at 100 degrees Celsius. That's where your boiling will occur. But evaporation can also take place. Sometimes when you see when you have a puddle of water on the floor, okay, your puddle of water you don't boil it to 100 degrees Celsius, but still evaporation can take place, and after sometimes you'll notice that this puddle of water on the floor, it can be evaporated you'll be gone after a few hours. Alright, but it does not boil because this evaporation actually takes place and it occurs at temperature below 100 degrees Celsius. Right? And for boiling, this boiling takes place throughout the liquid, but for evaporation, right, evaporation only takes place at the surface of the liquid. Now your boiling is also a very fast process, whereas your evaporation, like what I've mentioned just now, is a very slow process. It may take hours or even days for evaporation to finish taking place. Now the next part that I want to talk about is your sublimation. Now this is something that is new to you and is a very interesting process. Sublimation is a process in which a solid changes into a gas without passing through the liquid phase. Now in this change, heat is absorbed during your sublimation. So sublimation actually takes place at a fixed and sharp temperature, similar to your boiling and melting. So some example of substances that can sublime is your dry ice, okay, I think you should have seen this before, iodine or your ammonium chloride. Now as you can see from the picture over here, right, when I have some solid iodine crystals over here and I actually heat them, your iodine is, because it's a substance that sublime, right, it will not melt to give you a liquid. Instead, it sublimes to straight away give you your purple vapor. Now, if you're interested in finding out more, you can go and Google it and watch some of the videos. They are very interesting. Okay, and hopefully we'll have a chance to do some experiment when we have time. Now, the next physical change that we'll be looking at is your condensation. Now your condensation is a process in which a gas changes into a liquid. Now this change in state occurs when a gas is cooled to its boiling point. Now, this time round, heat is actually released or given out during your condensation. And your condensation takes place at a fixed and sharp temperature that is actually equal to its boiling point. Okay, essentially this is the opposite process of your boiling, where you change from a liquid to a gas. For condensation, you actually change your matter from a gas to a liquid. Now, what is the graph called if the state change of a substance is from a gaseous state to a liquid state? So basically, we are looking at the opposite of a heating curve. What we are looking at now is a cooling curve. So again, this shows a diagram of a cooling curve. I have the axis, which is your temperature time graph. So again, I have A, B, C, and D. And you take a look, the shape, essentially, right, instead of going upwards, now I have a graph that is going downwards. Now some of the key questions similar to your heating curve, you need to know what does A represent, what are the states of matter present in B, C, D, and how do you actually interpret the graph using your kinetic particle theory. Now I would suggest you just take a look at this graph again and you try to guess, okay, if I have a cooling curve for condensation, what will be your A, what will be the states of the matter at part B of the graph, part C, and part D of the graph. Take a few seconds to just think about this. Alright, now once you have completed this, we can go and take a look at the graph itself. Now I hope you are able to actually get this. Alright, now this will be a cooling curve for changing a gas into a liquid. If you take a look for part A, this will actually be the boiling point of the substance. Okay, this is a fixed and sharp temperature over here. So what I have now is that I have a starting temperature. Alright, don't worry, question will tell you what will be the temperature that we are starting. Now slowly, as we cool down the substance, your temperature will slowly decreases until I reach the boiling point. So this is the point where in which your condensation actually starts. Alright, and again, when I have a change in state, your temperature remains constant. Alright, and after the condensation has completed, then will your temperature continue to decrease. So for part B, part C, and part D of the graph, for part B, if let's say I'm talking about condensation, the starting substance is a gas. So when I have my condensation taking place, the substance will actually exist in the liquid state as well as the gaseous state over here. And after your condensation is completed, then of course it will exist in the liquid state. Now, how do we interpret this graph then? Take note that the particles this time round, right, they lose energy and they move less. Now, as the temperature actually decreases, the movement of the particle will also decrease. So because they lose energy, right, they will move slower. The particles will no longer move rapidly and randomly in any direction over large distances. So this is the movement of gaseous particle. So what happens now is that the forces of attraction, right, between the particles, they are now able to draw the particles closer together. So at this time, the gas changes into a liquid. So this is what I have if, again, we will take a look at the same experiment using your steric acid, okay, for condensation. I have the same exact curve, except that now, for part A, I have 361 degrees Celsius, which is also the same as the boiling point of your steric acid. Alright, and the difference is now that at the starting part of the graph, part B of the graph, your steric acid actually exists in the gaseous state. Alright, when condensation takes place, it will change to your liquid state, and once that is complete, then your steric acid will exist only in the liquid state over here. So the interpretation of the graph, what does the graph show? Now the graph again shows us that the boiling point of your steric acid is 361 degrees Celsius. And the temperature of the gas actually decreases until it reaches the boiling point of your steric acid, which is 361 degrees Celsius, at which your steric acid will start to condense. Now next, we take a look at the next physical process, which is freezing. So freezing is something that you should be familiar with. It's a process in which a liquid changes into a solid. Now your heat is released during freezing, similar to your condensation. And again, your freezing takes place at a fixed and sharp temperature called the freezing point. Now please take note that the freezing point and the melting point, right, actually they have the same value. So for example, ice melts at 0 degrees. The freezing point of ice will also be 0 degrees Celsius. Now next, I have the cooling curve for changing a liquid into a solid. Again, everything is the same except that for part A over here, now I have the freezing point. For part B, I will start with a liquid. For part C, it will be a liquid and solid. And for part D, it will exist only in the solid state. Alright, so this is the only changes. The rest, the shape of the graph is exactly the same as what you have learned previously. So how do we interpret the graph? Now the particles, again, when your liquid is cooled, the particle loses heat energy and move less. So as the temperature decreases, right, the movement of the particle also decreases. So now the particles no longer have enough energy to move and slide around each other over short distances. And the forces of attraction between the particles are now able to stop the particles from moving freely, and the liquid actually changes into a solid. So this, I have the cooling curve for your stearic acid. Again, everything is exactly the same. Only thing that you need to take note is that now the freezing point of your stearic acid is here, which is your 69 degree Celsius. So what does this graph shows? Now this tells us that the freezing point of your stearic acid, which is exactly the same as the melting point, is 69 degrees Celsius. Alright, the temperature of the liquid decreases until it reaches the freezing point of your stearic acid, which is 69 degrees Celsius. And when at 69 degrees Celsius, your stearic acid will start to freeze and changes into a solid. Now we've come to the end of this chapter. Alright, please go and look back, listen, and try to understand what is being covered in this chapter. Pay attention to the graph for your heating curve and your cooling curve, and understand why when we have a change in the state, the temperature actually remains constant. Alright, so these are some of the more important part of this chapter.